Okay, so good morning, everyone. So thanks for joining us on this Saturday. So we appreciate your interest in what's learning something new. So first of all, I'll give a small introduction about our Technique 360 community. So it is a community initiated by COVID.co. So we do events on Microsoft technologies every month. So due to this COVID, like we are doing in person, but next month we have Global Azure Bootcamp, which we are planning to do it in person in Coimbatore. So if you are interested, you can just go to this meetup.com/technique360 where you can find more details about it. So today, like we have a session by Swami, like he'll be talking about Azure deployments with GitHub Actions. So this will be around 1.5 hours session. Like if you have any doubts or any clarifications, you can reach out in the comment section. Like we'll try to clear your doubts at the end of the session. So without much delay, so I'll hand over the session to Swami. So over to you, Swami.
Hey, hello everybody. Good morning and good evening if you're joining from a different time zone or so. And thank you so much for taking time out to learn something new. We really appreciate that, and that is the key which is motivating us to do more events, right? So with that, okay. So today we're going to talk about how we can use GitHub Actions to supercharge your, Azure deployments. So before we get into the event, a bit of introduction about myself. So my name is Swami. I work as an Swaminathan Vetri is a full name. So I work as an architect at Maersk, and I'm also Microsoft MVP under Developer Technologies since 2016. I'm also a member of .NET Foundation, and that's my Twitter handle. And I do write blogs. It's been quite some time since I did it, but yeah, I maintain my blog at swaminathanvetri.in, and I also recently opened a YouTube channel during this pandemic, so you feel free to subscribe to that channel as well. And that's my GitHub handle, SV Swaminathan. And apart from tech stuffs, I'm also interested in photography, blogging, traveling, and I do a bit of home automation. Right. So, what is the agenda for for this session? Right. So, we'll start with I will start by getting the understanding of what are GitHub Actions, and then we'll understand also why we need to use GitHub Actions, and then we'll walk through some of the core concepts, and we'll then jump straight into the demo. Okay. I don't have a lot of slides, so it's going to be more of an demo and then like a walkthrough kind of a session. So, feel free to ask any questions via the YouTube channel or the YouTube chat, and then we'll be able to take that up. I want to make it more conversational as much as possible with the limited resources we have with the virtual events, right? But yeah, let's do our best. All right, so what are GitHub Actions to start with, right? So GitHub Actions is something which will help you to automate any workflow. Okay, it will help you to take any of your ideas to production, right? You can automate everything and anything within GitHub. When I say anything and everything, what are some of the examples, right? So one of the typical developer-centric thing is a code reviews, right? So if you want to automate some of the code review processes, whenever you create a PR or whenever you want to label some of the issues and things like that, right? You could very well do that with GitHub Actions. And also, if you want to also manage branches, that for every release, if you want to automatically create a new branch, or if you want to automatically tag a new release or anything like that in your workflow, right, you can very well do that too. And issue triaging, for example, if you're running an open source project or open source project, yeah, and then if you want to triage certain issues, let's say if somebody is creating an issue on your documentation or somebody is creating an issue on your core functionality, if you have multiple functionalities in there, how do you label some of those things automatically when someone creates an issue, etc., right? All those things are also possible with GitHub Actions. And of course, apart from all these things, the primary focus is also on the CI and CD, which is nothing but the continuous integration and continuous deployment, right? You can also do that with GitHub Actions. And in this session, we are going to primarily focus more on CI CD. One is for the infrastructure, how you can create Azure infrastructure using GitHub Actions. And second is how you can deploy your code into that infrastructure, right? That's what we're going to see in the demo today. And of course, there are a lot more things you can do as well. right? But then why GitHub Actions? I'm sure a lot of us would have used a lot of other tools doing the similar things, right? Like Azure DevOps is one other example, or GitLab and different other things are there, right? So why do we need to really go with GitHub Actions, right? So some of the points are like this, right? So GitHub Actions works on across all the platforms. So if you want to run your builds on Linux or Mac OS or Windows or ARM or containers, you can do everything in GitHub Actions, right? And also there's a concept called matrix builds. That's nothing but, let's say if you're creating an JavaScript library, for example, right? And if you want, you might need to ensure your library is supported across multiple node versions, node 14, 10, 12, whatever be the latest versions and things like that, right? And the same lines on the .NET developer. If you're a .NET developer and if you're creating a .NET library, you might want to ensure you are providing support for the LTS plus the new releases and things like that, right? So for example, .NET 3.x or 5.x or .NET 6.x, etc. So as a library author, if you want to see whenever you make any code commits, if how do you ensure if this particular code is compatible across all of this? If you want to run a build parallelly for all of these, targeting all of these different SDKs like .NET 5.x or 6.x or 3.x, etc., you can use something called a matrix build. That is also another important feature and a cool thing to do with GitHub Actions. Right? And of course, it supports any language, so you can think of anything, either .NET, Java, Python, Ruby, Node, whatever be the language, you can set up your builds and everything with GitHub Actions. And as and when the job runs or the action runs, you will get the live logs of it. You can very well monitor it from the GitHub itself. We're going to see that in the demo as well. And it also comes with a secret store. So for example, if you want to deploy certain thing into Azure, you would need to maintain some of the Azure service principles and credentials and things like that, right? So you don't have to use any of the external entities to do that. GitHub itself has a built-in secret store in which you can put all of these credentials, and then you are good to go. You can use them inside your actions, and then you'll be able to do the deployments and everything. And also multi-container testing. So if you want to run multiple containers, if you want to run your testing within multiple containers, and if you want to bootstrap some of these with Docker Compose and things like that, you can very well do that in the actions as well. And of course, it's open source, so you can see, if you can go to GitHub Actions repository itself and then see how it is implemented. And there are also a lot of community powered workflows are available, so you don't have to really start from scratch. Let's say if you want to build a .NET application, there is an workflow available. If you want to build a Java application, you have an already workflow available. If you want to publish something as an artifact, if you want to push data into Azure Blob Storage, I'm just taking some of these random examples, right? Some of these are already taken care of by the community, and then we can reuse some of these workflows, and then we can get the best benefit out of them. Okay, now talking about some of the core concepts, right? So I would like you to go from bottom to the top. So the lowest granular entity in a GitHub action is the action or a task, right? That is where you will say what needs to be done. It could be as simple as a bash script, or it could be as simple as any other usable task where it runs a bunch of activities, like doing a checkout of a code, or doing a .NET build is a command that runs, right? So running that command is going to be one of the tasks or one of the action. Or it could be creating an issue in a GitHub repository, or it could be updating a comment in an existing issue, or updating a comment in an existing PR. All of these are some of the examples of actions, right? And a bunch of these actions is what would comprise a step. So a step would have multiple actions in it, and multiple steps would comprise a job. Rather, a job comprises multiple steps, right? When you define a job, you'll define multiple steps inside that, and within each of those steps, you'll have multiple actions. So the example of a job could be like in build. Build could be one of the job, and in the build job, you will do maybe first check out the code, and then build the code actually, and then when you say build, compile the code, and then run unit tests, and then run sonar coverage. So each of these could be individual steps, and then an entire thing is surrounded by a job. And there could be another job which is called deployment job. In that deployment job, you could basically deploy things into either an Azure, you can deploy into multiple environments and things like that, right? And all these jobs are comprised in a workflow, right? That means you can also have multiple jobs. And when you define two different jobs, unless you specify the dependencies, they all will run in parallel, right? So let's say, for example, if you want to run multiple flavors of your build, let's say you want to run one in Mac OS, and we want to run in Windows, and we want to run in Linux, etc., right? Like I said, you can use a matrix one, and then the job will run in multiple in parallel, basically. And yeah, and where does all of this run? This all are going to be run by the cloud hosted runners. That's what is called a runner. So everything is provisioned by GitHub for us. There are of course free limits available for open source projects and other things. And also again, dependent on the multiple licenses what you have, whether if you're on GitHub Enterprise Cloud or if you're in GitHub Teams and things like that, you have a different price point for each and everything. But net, you have an option to run all these things on the cloud, Or you also have an option if you want to have a full control of the runners. You can also very well do that by using something called self-hosted runners, right? So just to recap, runners is the one which is going to execute the workflow, and within that workflow is where you'll define multiple jobs, and within the jobs is where you'll define multiple steps, and each steps could have multiple actions, right? So now there are some more things to it, right? So there's something called event. So what is going to trigger that particular workflow, right? That is where the event comes up. Some of the examples of the events are listed here, right? So it could be a push. If you push a code to a repository, so that is one of the event. Or whenever you create a pull request, that is another event. Or whenever an issue is created, this is where you use kind of an issue. Issues is the event which you use for issue triaging, right? You can also use that as an event to run a workflow. Or whenever a new release is created, that these are all some of the trigger based events, right? Or what if you want to run something on a daily basis or on a scheduled basis? You can also very well do that with a cron expression. So these are some of the events that could trigger the workflows, right? And when that workflow runs, it definitely produces some output, right? For example, if you're creating a .NET application, you'll generate a DLL. Or if your output is going to be a Docker image, the Docker image is going to be one of the artifacts, right? Or if you are writing a unit test, or if you're running a unit test, then that unit test report is going to be one of the artifacts, right? So some of these are called the artifacts, and they are all part of the build itself. It will be available as part of the build. I'll also show in the demo, right? So some of the examples that could be binary files, which is nothing but the DLLs or jars and things like that, or it could be test results, or if you're running some sort of a new automation, you can also maintain the screenshots and everything there, plus of course the logs of your builds, right? So apart from this, like I said, self-hosted runners are another concept. So by default, if you are an open source, but if you don't want to invest on infrastructure and then maintain your own runners, you can very well rely on GitHub, and then you can use the self-hosted runners, and you can use the cloud-hosted runners, and then you can do your job, right? But if you're an enterprise and if you want to have a control on what machines you want to run your builds, or for example, if some of those runners are not available in GitHub, I think one of the examples I've seen is the Red Hat Enterprise Linux is something which is a specific variant, which is not available as a default runner there. If in case you have such specific needs, and if you want to have full control over the machine and the hardware and the software, what it needs, what it runs, right, then you can go for self-hosted runners. So that means what would happen is you'll have your runner in you, basically your machine would be added to your GitHub repository or the GitHub account, and then whenever a job is triggered, the job will get executed on your machine. It could be anywhere. It could be an Azure hosted VM, or it could be your local machine, or it could be in any VM in any part of the world. As long as you set up the runner and then set up the communication between GitHub and this particular runner, all the jobs will then get started executed in this runner, right? So those are some of the basic concepts, and then with that, I think we can get straight into the demo, and then maybe we can explore more on what are the other things we would learn, right? So for the demo, I am going to. So these are some of the things which we would do in the demo today, right? Like I said, as and when you have any questions or anything, please feel free to stop or ask, and then I'll keep a watch on the comment section here. Right, so we'll get started with GitHub Actions. Let's go to the GitHub repository and then see how to get started, and then we'll go through one by one of these. Okay, so without further ado, I'll get started here. Okay, so I kind of created a repository. I'll also ping this repository here, and then you can take a look at all the things whatever we are doing here. I am pasting it, so either Suhas or Kuku, please post it in the YouTube chat so that people can look at this as well, right? Yeah, so before we get into this, so if you want to learn more about actions, the easier way is just go to, like I said, GitHub Actions, and then go into the documentation, and you should be able to look at that. Yeah, so whatever I've just explained is all much clearly talked about here, and any workflow and any GitHub event and things like that, right? You can also take a look at all of these and get a better understanding. And if you want to look at the actions repository itself, you can also go to GitHub and then do that. github.com/actions/actions, and this is where the documentation is. You can go ahead and get started. So there is also a live lab as well available. I think it should be somewhere here. You can learn there's a step-by-step process which is available here, with which you can understand what GitHub action, how to get started with actions and things like that. Okay, so with that, let's now go back to our repository here, right? So what I've done today for today's demo is I have a Terraform code. I'm not sure how many of you understand Terraform. Maybe I can also touch a bit on that, right? So Terraform is an infrastructure as a code tool, right, with which you can create infrastructures by writing scripts, right? If you are familiar with Azure, you might have heard something called ARM, right? Azure Resource Manager templates. And then there is a recent evolution of it called biceps, right? So those are something which are specific to Azure, right? When you write your ARM template, or if you create a bicep code, and when you deploy that code in Azure, your resources would get created, right? And why do we use this Terraform on this kind of infrastructure code? It is to create more repeatable resources, basically resource creation in a repeatable manner. And also you can also put in a lot of these, it's more of an, what to say, your code and your infrastructure, everything is maintained in the same repository. So you get on full control on what is really present. So looking at the GitHub repository itself, you'll get to know, okay, what kind of infrastructure we're going to create, right? And imagine if you want to create the same infrastructure in multiple environments, like you have an Azure web app, and if you want to create it in for a dev, QA, pre-prod and prod environments, right? Going to a portal and then clicking and creating is not going to be very efficient. That is one. Plus, there could also be multiple access level restrictions, right? Not everyone will get access to your production subscriptions and things like that. In such cases, using some of these automation tools would really help, right? So in such automate, when we talk about the infrastructure automation tools, Terraform is one of the most popular tools. It's again open source one, and it's also done by HashiCorp, right? Which will help, which works on the concept of providers. It's how it works is when you create a script. For example, I'll just talk about this here, right? I'll maybe, so you will create something like this. You'll have in Terraform, and then you'll mention backend as an Azure RM, and this is some of the settings I've done for the Terraform to work. And you'll mention something like a provider, which is an Azure RM provider. That means Azure Resource Manager provider. This is the version of it I'm using, right? So with that, what would happen is, let's say if you want to create a resource group, right? You will just simply tell like this resource, and then this is the Terraform's module or the resource for Azure resource group. You'll just say Azure resource group. This is any name I can give, and this is the resource group name and location, right? So like this, you can define all the different resources. That's here I'm trying to create an app service plan, and then I'm also trying to create a Linux web app. These are the three resources which I've created, right? You'll just create something like this, right? And then what you would do is you would use Terraform has multiple steps to do, right? You'll say Terraform init. When you say init, it will go and initialize all the backend for it. So what does this mean by backend is, let's say, since like I said, it's an infrastructure as a code, right? Terraform needs to understand what is expected, which is defined in this particular script file, right? And what is already present there in the Azure side. That is what it will try. It's called a desired state configuration, right? So we are trying to go from whatever state in the production or in the Azure, and we're going to go to that state from here, right? From whatever we're defining in this particular code, right? So it needs to maintain that state somewhere. That is why it uses this backend. So basically, I've created a storage account for that particular backend, which is what this storage account, which is done separately. I mean, this is more like a one-time activity, right? So I've done this backend. So basically, whenever now I try to run this particular script, it will go and validate whether all the resources already exist in it or not. If not, it will go and create it. If they exist, it will try to identify what are the differences between the resource that is mentioned in the code versus what is present in the Azure side, right? Then it will do the difference of it. That's how Terraform works at a high level. It Now this is not a Terraform session, so I'm trying to keep it a high level so that you get a basic understanding of that, right? So yeah, the workflow, what we're trying to do is whenever there's a PR that is created to this particular code, we will our GitHub Actions workflow will kick in, and then that is going to do the steps for us. Okay. So with that said, so that's one of the things which we would be doing. And again, we also have a .NET application. We'll also see how we are going to deploy the .NET web API into that particular resource group and the web app what we are going to create. Okay. So now let me go and open our. So some of the prerequisites, if at all you want to follow whatever is present in this particular demo, right, or whatever I've added in this particular repository, I think I've added some of the prerequisites. If not, you can go and look at this AZCLI file, right? And then you need to do all these things initially. You need to have an Azure account if you want to try it with Azure. And again, in this demo, I'm going to talk about GitHub plus Terraform plus Azure. But all these three, I mean, GitHub and Terraform can work with any of the cloud. If in case you want to create your resources in AWS, you can very well use with Terraform, and you can also very well set up the pipelines with the GitHub Actions. Okay. For this session, I kind of scoped it to Azure and the .NET plus Terraform based deployments. So you do an AZ login once you have an Azure account, and then you just create some of these resources. And once you're done with this, you need to also do some more setup in the repository level. So which I will just show here. So if you go to these settings, and I believe it's in the environments. Okay, sorry, not in environments. I think it's in secrets. Oops. Yeah, so if you go to action secret, I have just added some of these secrets. So these are the repository secrets: Azure AD client ID, AD client ID secret, tenant ID, and subscription. So you will get all these as an output of this command when you run, right? When you're creating an SPN, this is nothing but we're creating a service principal. Okay, if I can just take a minute to debrief this, right? So first we're trying to log into Azure, and then with the active subscription, we are going to create a resource group, which is what I just created using the South India location. And I'm trying to create a storage account in that particular resource group. Right? Storage account name is stcoveco tf state, and this is the container what I'm creating within that storage account. Right, and then I'm just trying to create another SPN. SPN is nothing but a service principal. This is like to perform any automations with Azure, you would use an SPN, so that it doesn't ask you. You don't have to really have any user doing it. It is more like on behalf of an user, a service principal will do that particular activity. Right, so that is what I've done here, and the output of this command will give you four or a couple of options basically. One is the client ID, other is the secret, and then the tenant ID and the subscription ID, which is what I kind of add into the secrets. So this is this built-in secret store which I talked about in the presentation, right? In any repository, you can go to that particular repository and then set up a secrets. Right, and what I have done is a single repository specific secrets. But if in case you are using a GitHub organization, right, you can very well create these secrets at an organization level as well. So when you create something at organizational level, that means all the repositories within that particular organization will automatically inherit these secrets. Okay, so for this demo, I kind of maintain it at the repository level. And there are also environment specific secrets, which maybe I'll touch upon maybe later. So there's a concept of environments, and where you can define dev, prod, and everything, and then you can also associate secrets to that specific environment. Okay, so that is the secret setting I did. Right, now before we go any further, I'll also show how to get started with the actions. Right, I know I'm kind of digressing between actions and Terraform. I thought I'll just give some brief about Terraform. So now getting back into the actions, right? So imagine if you don't have any action set up in your repository, right? If you go to the actions tab, then you'll see this workflow and the new workflow. Right, what you could do is you can just go ahead and click with new workflow. Right, and then as you can see, there are already multiple options available. Right, and one other good thing is GitHub in this repository, since I have a .NET code, it was able to identify there's a .NET code in it, and it kind of suggests this particular workflow for me. Right, I can either start from here by configuring this, or I can go ahead and choose something else as well from below. And all these are built-in workflows available. You just need to configure them so that you are good to get started with it. Right, excuse me. So for example, now let's say if you want to set up another .NET thing, right, I'll just say configure. Right, maybe I'll say .NET live demo. I already have one, so I'm just naming it as a live demo.yaml. So here is where you can go ahead and the font is visible. Okay, here is where you'll go ahead and create your workflows, right? So these are the section which I called as an events, right? If you recollect, there were multiple events which we talked about, right? So on is what that means. On what event we need to trigger this, right? And we're telling push is one of the events. And push to which branch? If you don't specify any branches, it will run this for every branch push, right? And what we are trying to do is we are restricting this to master branch pushes. Right? And whenever a pull request is created to a master branch, then that is when this is going to run. Okay, this is the event, right? And this entire file is called the workflows, and where this would get created is under this workflows folder. So in your repository, there will be a new folder called .github would be created, and inside that there will be a workflows folder created, and inside that is when you'll have this YAML run. Okay, so this is the name of the workflow. Maybe I'll just say .NET build workflow. Right, you can create any names, and these are the events from which on which it should run, and these are jobs what we are specifying. In this case, there's only one job, right, which says build, right, and this runs on Ubuntu latest. This is what is the runner, right? So this is the job name. It could be any name here. The default it is showing as build, so I'm just going to leave with that. And runs on means this job is, or this job build is going to run on this Ubuntu latest VM. So here, when we commit this, GitHub will provision an Ubuntu latest VM for every run of this workflow, and it will just run there, and then that VM would get terminated. Okay. So yeah, and these are the different steps. Like I said, so these are the steps, and uses is what you will use to reuse any of the actions, right? So this is, like I said, this is something which is available from GitHub itself, right? So as you can see, by actions means that is all coming from the GitHub itself. These are all like verified ones, the ones with the tick. If you search for .NET, you might see multiple other things as well. See, this is something some other community person has created this in P3 and SecByte.NET Sonar Scanner and things like that, right? So you can choose any of these as well, or you can also choose some things which is verified by the GitHub or Microsoft and other actions as well. You can use. So now we are using this action. So for example, how this would look at, right? Let me say .NET setup.NET. Yeah, setup.NET Core SDK. If you want to reuse this action, you just click on this here, and then it will show all the steps, right? So this is how it is going to run. So setup.NET at v2.o.o with, and then you will specify all the different parameters, right? So when you define an action, you can define all the different parameters for that action, right? Or the inputs for that action. That is what would goes here under this with. So here what we are saying is we are going to set up .NET with .NET version 5.0.x. But what I have created is 6.0.x. So I'm going to modify this to 6.0.x here, right? So if you want to pick any of the actions from here, this is how you will do. You can just go ahead and copy from here, paste it in this side, and then you can directly, use that. Whether you want to use the in pre-releases you want to include and things like that, all the options would come up here. Okay, so which is already present here. This is like a reusable workflow that is available as a template for us, which is what we are leveraging here, right? So set up .NET, and then what all the things we will do, we'll do run restore dependencies, right? So what basically this step does is it is going to install this .NET SDK into this particular Ubuntu VM. So we will have the .NET available in the path. That is when you are able to say run .NET restore, it will understand the .NET SDK present, and then it is going to do the restore, and then .NET build will do the .NET build, and then .NET test will do the .NET test for us, right? So this is how you would create a workflow, and you can very well delete and add and everything here, right? And this also has an how to say intelligence here. So I'll just say maybe name colon, I'll say maybe I'll open something else. Maybe I'll show that intelligence when we really modify some of these things later in the demo, right? But this is like getting started part, so I hope that kind of that is clear now, right? One way is as you can see the tip here, use control space to trigger autocomplete in most situations, right? Whether you want to know how you will add things, etc., you can very well put an this one control space, then you can identify that. Yeah, so now to for us to, let's say if you want to start afresh, right, then you will go ahead and do a commit. Since this is a demo repository, I'm going to do a direct commit to the master. You'll always do an PR based things, right? So I'll commit a new file. And when I commit this, as you can see that these are the other two workflows which I had already, and this is a newer one. And there are no limits to what kind of workflows you want to create, how many workflows you want to create or anything. It's completely up to you and what you want to accomplish in that particular repository. Right? You can have one for deployment, one for build, and one for maybe issue triaging, one for maybe welcoming a new contributor, and the possibilities are endless. Okay. So now if you go to the actions, it should have created one because we kind of ran this, and that's a good start for the demo. What does it say? Okay, I think the path is a problem. I think I left everything as a default, right? Yeah, so if you look at my, basically this will try to run things from the from relative path is what it looks at, right? This is present within the .github workflows folder. So it will look at the parent folder would be your working directory, and in that working directory it is trying to find out if there are any .NET solutions, which is obviously not there, right? Because my folder structures are different. So to fix it, you can go here inside this, and then you can maybe set up whatever is there is the build path and other things, which is exactly what I've done in this particular file. If I now take reference of this, right? So I've given the paths as .NET Web API as because, okay, this is another interesting thing, right? So in this repository, again, that is one of the things which I want to stress out. That's why I kind of create the repository in this way. So it's a single repository which is having both your code plus your infrastructure, right? And this workflow is something which is specific to your .NET code, right? And that .NET code resides within this particular path in my parent folder, in my root directory. That is why I'm telling if there are any push that is happening to this branch and within this path, right? So that means if I commit Terraform code, this workflow would not run, and it doesn't make sense to run that also, right? So that is what we are trying to accomplish by mentioning the paths here. The same thing, whenever there is a pull request that is happening, I will also, whenever a pull request that goes inside this particular path and this branch, then we run this particular workflow. Okay. And also there's something called workflow dispatch, right? So all this while I talked about the CI part. So what if we want to run a particular build manually? That is where this workflow dispatch would help. I'll quickly show how it is going to work just after debriefing this particular file, right? And this is how you'll define an environment variable. We are telling environment as .NET project path, which is .NET ./.NET Web API. And that is the project path I'm using. And then publish path is ./publish. And again, this is a bit modified version of that default template. So what I'm doing is .NET restore, and then go inside that path, which is environment.net project path, which is nothing but /.net web API. Right? That is from the current folder, go into .NET Web API /.NET Web API.cs. That is the project file we are trying to restore. And it's the same thing in build. And then when we're trying to publish, we are publishing into this environment path, right? Publish path. And what we're also doing is we're trying to upload the artifact, because only then you'll be able to again download it in another job, and then you'll be able to deploy it, right? So what we're doing is we're uploading a build artifact here with action/upload artifact, and .NET Web API demo, and then the path is environment.publish path, right? Okay, now let's also quickly understand how this is working, and then maybe let's try and create afresh. So to trigger any of the actions manually, you can go to .NET build here, right? So you'll see this run workflow. It says this workflow has an workflow dispatch event trigger, right? Because of that only it is having this option. So this is one of the option to create your workflows in a manual way. Okay. So I can just go ahead and say run workflow. You can also add any inputs if you want to specify some of the inputs to your to a workflow. You can very well do that. 1 minute 17 seconds when this is run. Will it refresh? Okay, yeah. So number 6, which is started now. Right. So this is one of the jobs, and deploy part we'll get to it next. I just wanted to focus on the build job now. Right. So if you click on it, this is the live logs what we were talking about. Right. So you can see all the different steps, whatever it is running. See, this is the runner what we have got. The operating system is Ubuntu 20.0.4, and then this is the virtual environment, and all the GitHub permissions and everything, right? So you can see what are the basically you can see the logs of each and every action in this particular page here. Okay, and at the end of it, we kind of uploaded the build artifact, right? So we did .NET build publish, and then we are doing an artifact here. Okay, and then it triggered the next job, which is what you would see from this. If you go to summary. So this is complete, and then I kind of made this deployment to wait until the build is completed. So obviously only then we'll be able to get the artifact and then deploy it, right? So which is what is happening here. Okay, so now if you come down further is where you will see the artifacts. So like I said, the artifacts, because we kind of publish the artifact, it's available here. So if you click on this artifact, you'll be able to download that artifact, whatever is created out of this particular build. Okay. So that's how you can see how a particular workflow runs, and then what are the outputs and artifacts and etc. So you can go and look at the workflow file from here. That will take you to your actual GitHub workflow file. And you can also, if there are any failures, you can rerun the jobs, and you can also create status badge. So that part we'll get to it next. Right. Okay. So just for me to keep track on what I'm doing, let me go and open this demo. Okay. Yeah, we just learned about how to get started with GitHub Actions, and then we got a walkthrough of the documentation, and we did set up the environments and variables. Yeah, and setting up environments and branch protections on environments. Yeah, maybe let's do this now, right? So I hope it's kind of clear and you're able to follow me. If there are any questions, you can just always ask. Okay, I don't see any questions there. So I hope it is all fine. Okay. So now I think just to recap, so far what we did is we understood what is GitHub Actions, and then we saw how to create a basic workflow by using the reusable templates which are available, right? And then we just triggered some of the existing workflows, right? Now let's start building things on our own now, right? So first thing is, like I said, we have to set up the environments and the secrets. So if you go to environments, you can create any number of environments here. I'll create one environment called prod environment, right? That is what's going to be production. And I'm going to say configure environment, right? So we can specify whether we want any of approvals to be done or not, right? So whenever there's a deployment that needs to go to the prod, I would want someone to really approve it. In my case, since I'm the one showing them, I'll just put my name, right? And then you can also set up the wait timer, how long you would need to wait for the approval. Is it like 10 minutes, 5 minutes, or whatever, right? You can specify that. What this would do is anytime a deployment is targeted to that environment, the approver needs to approve, only then it will proceed further. Okay, we will see that in the demo as well soon. And the deployment branches, so from which branch you would want to deploy into the production environment. That is also something you can set up here. So this is again linked to your branch protection rules at the repository level. So for example, I don't think I have set up anything here. Let me go and set up something. Yeah, so default branch is master, and let's say for master branch, I will just set up this master branch rule here. Require a pull request before merging. right? And it requires approvals. In this case, since I'm the only one, I don't think I can put this. Yeah, I'll just say, yeah, so request status checks to pass before merging. I can put that check, and I will just create this branch rule. Yeah. Okay, so now you can go to environments, and then you can also see that you can apply this branch rule. Yeah, right, so applies to one branch. The master branch rule is applied. So that means what basically two things we are doing here. One is how we are going to get the changes into the master branch. That is one thing we have set it up using the repository branch protection rules, right? And then only when there are any changes that is going into that particular branch is when their production deployment would be applicable. Let's say you create other feature branches, and then you're creating multiple features, and then you are committing it to the feature branch and other things. Then those feature branches will not get deployed into your production. Obviously, we don't want to do that, right? We want to deploy these feature branches either into your dev environment or wherever, but not into the production, which is what we are trying to accomplish here. Okay. And the secrets part, we will add it whenever we create a new secret, right? So this is how you'll go ahead and configure the environments, and then you'll use that environment in the appropriate workflow files, right? So we just did the environment creation as well. And then, yeah, I think we talked about the Terraform prerequisites and their setup. And okay, so now let's go deep into the Terraform workflow. So what we're going to do now is we are going to create new resource group, new Azure web app, and Linux, basically Azure app service plan, and then an Linux web app, and we'll try to create the infrastructure first. Okay. So for simplicity, what I'm going to do is I'm going to modify the same main.tf file, right? And I'm going to add more things into it. So these are all standard ones which are not going to change. And what I'm going to do is I'll just copy paste this resource group. I'll also show how this Terraform works now, right? So this one, I'll say maybe RG Coveco demo prod. Okay, that is the name of the this name corresponds to the state, right? When Terraform maintains the state of this, it will maintain against this name, and this is the actual name of our resource group. Okay, so I'm creating this resource group, and I'm also going to create this app service plan. Maybe I'll reuse this app service plan for the service code demo prod. Okay, this is a name, and this was group name. I need to use this resource group here, right? So I will say rg code demo prod dot name. That means this particular app service plan is linked into this particular resource group, and these ones I'll remain as is. And again, just another word of caution, right? So you don't necessarily need to do this way to create multiple resources for in multiple environments, right? You would use something called a Terraform module just for simplicity, and I don't want to confuse too much with the Terraform bits, so I'm just trying to create this as a separate resources. Okay, that would need a session by itself to talk about Terraform modules and other stuff. So for simplicity, the key focus is more on GitHub Actions. So I'm just trying to create this way. So Coveco demo prod. I'll do that, and then I'll change this as well. Resource group name should be this resource group, right? Okay, and the location is going to be this location, wherever my app service plan is going to be, and service plan ID also this service plan ID. Right? And if you want to understand how to create these resources and what are the other things, Terraform documentation is the place to go. So you can go to Terraform plus Azure App Service, something like that, right? Then you'll get to the Terraform App Service registry. Basically, you can go here and then understand how these different resources or what are the different things you need to add, right? This has a pretty neat documentation. You can just pick up some of these from here and understand what values goes into each of these properties from the documentation here, and then just push them there. Okay, that's exactly what I kind of did here. Yeah, here, no? Yeah, so which is what I did here. So yeah, so this file is kind of ready. So now I'll go ahead and push this. And again, when I push this, it is going to run the Terraform, and when it runs, I'll kind of explain what it does in that workflow. Okay. So yeah, so these things, it is fine. I can skip that. So in here, okay, I removed that line, and then we added 3 resource groups, right? So one is the Coveco demo, ASP Coveco demo prod, and then the web Coveco demo prod, right? This is what we've created. So good to go. I'll go ahead and add this. Okay, before that, I'll create a new branch from here, feature slash live demo creation. Okay, branch, and then okay, let me go ahead and add a resource for prod. Okay, and that, and then I'm going to push that. Yes, because the branch doesn't exist in the remote, it asks that, and it should be pushed there now. Okay, let's go back to GitHub and check. Okay, so it says there is already an push that happened, right? So now if you go to the actions, nothing should have run. Yeah, because there are no Terraform workflows running, right? The reason being, in that Terraform workflow, what we have done is it says pushes on branches to master, right? That's why nothing has run. Right. So now what we'll do is we're also telling there is a pull request that when that is created against the master branch also this should run. Right. So let's go ahead and do that. So let's go back to the code here and then say compare and pull request. Yeah. So this is what is the changes. I'm going to create a new pull request now. Okay, so I have this pull request ready, and now what it should do is, because there is already this workflow available in it, right, which looks for the pull request, it is doing this. See, now as you can see, this guy runs now. That is because we didn't specify the paths, right? That is the importance of the path. This is actually not necessary, which I'll go and fix later. But our interest is now this Terraform plan, right? So let's go to Terraform plan, and yeah, so we are doing some of these steps here in the Terraform thing, right? Like I said, these are the environment variables I'm passing it, so that Terraform would be able to use some of these, and then it will be able to establish communication to the Azure storage where the state is maintained, and it will be able to identify the differences. Okay, so of course, checkout is the first thing what you would do, and then we're trying to do a Terraform format. This will tell us whether all the Terraform files are in a proper formatted way. Right? And the working directory we are specifying is /Terraform, because that is where all the files are present, right? Under the parent folder, there is this Terraform folder. That's where this file is present. Right? So we are doing a formatting of it, and then we are doing init. Init is when it will, like I said, it will establish a communication to the storage account, and then it will load that storage, and it will be initialized then. And we're doing a validate here that will do if there are any kind of misses. Let's say, for example, one of the examples is when I go to documentation here, right? So the site config is something they say it's mandatory, right? This is something which is mandatory for a particular app service group. Okay, so here it says required, right? What if you miss one of these, right? So that is what you will get to know as part of your validation. Then your validation could fail, and then you'll understand that, yeah, maybe something is missing which is required, and then we can go ahead and fix that. That is what is validate and then plan. And what we've also done is, so as you can see, you need sorry, I think I was explaining here, right? Yeah, we're doing a validate, and then we're doing a plan. Plan is nothing but it will read through the new TF scripts, and then it will compare that against the state there, and it will see what are the differences. Okay, we'll also expand this here now and see, right? If you go to the plan, so it says, see, Terraform will perform the following operations. This plus means create, right? These are the operations I'm trying to do. See, it is going to create Linux web app, right? Web Cove, code demo prod with all these settings. And then it will also say, yeah, another resource is RG Cove code demo prod. And then it says ASP Cove code demo prod. That means it's also going to create this app service plan. So in the end, the summary would look like this: plan 3 to add, 0 to change, and 0 to destroy, right? So this is how you can check these statuses, right? But what if we want to push the status into the comment as a comment in the PR itself, right? Now, if you go back to the PR, so what we also accomplished is these GitHub Actions results have come up here. See, these are the commands which you ran, right? Terraform format and style success, initialization success, Terraform plan success, validation success. So now looking at this, it's easier for any of the reviewer to see whether they want to approve this particular, merge this particular PR or not. Right? I'll also explain how this part is done now. Right? So going back to the code here. So there is a thing called GitHub action script. There is an action called GitHub script, right? And what we are saying is, if the GitHub event name, in this case, our event name is pull request, not a push. So whenever this pull request is created, And when this workflow runs for a pull request, we are kind of doing these activities, right? With the GitHub token, secrets GitHub underscore token, and then this is the script what we are forming, right? Basically, we are trying to formatting all of these aspects: Terraform initialization, Terraform plan, validation, blah blah blah, and then this is what it is doing. This is the snippet that is creating that particular comment. See, GitHub rest.issues.create comment with the issue number as whatever the issue number and the owner, repository, and the body. So with this, we are able to basically streamline the process of creating pull requests and managing the pull requests as well, right? Basically, the reviewer don't have to go into actions and then look at it. Here itself, what there are two things. One is the checks itself will tell us whether all the checks are fine and they are up and running, or they are all successful, right? And then second part is also, if you put as a comment here what is working and what is not working, then it's very easy for the reviewer to go and merge the pull request, right? So now, yeah, I'm kind of happy with this. I know for a fact this is a wrong one, so that failure I'm okay with it. So I'll go ahead and say merge pull request, right? So I'm going to say confirm merge. Okay, and whenever this is merged, then our another action should run, which is on the push to master branch, right? Now, if I go to Terraform, you can see the merge pull request has already triggered this particular action, right? And in this, what we're doing is basically we are running the entire all the steps, and this apply alone, if you look at it, there's an if condition again mentioned, which says if it is a master branch, we are going to run this, right? Which is what is going to happen now. So you should pretty much see all the steps plus apply as well happening in this. So yeah, we can go and look at that. And one as this loads, maybe I'll open my Azure portal so that we can quickly check there. Okay, so here if I go to resource groups, so now, so we don't see anything like an RG Coveco demo or anything like that, right? So when that particular apply is complete, we should see that new resource group getting created there. Okay. So I'll just pause for a while. I think I've been talking for 45 minutes. So are there any questions? Feel free to ask any questions, and then we can go and validate this and move on to the next one.
Till now, there are no questions, so it's fine.
Okay, great. So I hope either everything is clear or completely unclear. Feel free to add your comments as well, right? Because it's kind of boring to do an one-way talk on a Saturday morning. So yeah, so this is doing the apply. This might take a few minutes depending on how many resources you are trying to create and what is the amount of what is the state of your state, Terraform state, etc. Right. So as this runs, maybe I'll go ahead and quickly show the Terraform state where it maintains. Right. So if you go to resource groups, I created this Coveco TF state. Right. So in this, I have this what to say, the storage account, and inside this, I have this containers. And here is where this is a state file basically. So it creates this, and it keeps updating this as and when things happen. I don't want to open this now because Terraform apply is happening now. So maybe we can take a look at it once this is complete. This maintains in like a the JSON format. You can also download this and then see. But one quick request is don't try to tamper anything with the state, because if you do anything with the state, what would happen is your further deployments will get messed up, because everything is compared against the state. And if that state file gets corrupted, then you might see undesirable results in your infrastructure. Okay. Well, so let this run. Okay, it says it is all doing this. Okay, 3 added is what it says, right? Now this entire job is complete. Okay, I think I missed one part. I missed to change one thing. Okay, that part I think I'll add there. That's fine. Yeah, I also put all these things in the README here, right? What happens, GitHub Actions for simple Terraform-based infrastructure. So for PR, these are the things that happened, which we just saw. And when we push into the master branch, it got created, right? Now, assuming it's already available here, let me go ahead and refresh this. Yeah, I think we see it there, right? Gcoveco demo prod. So we were able to create this infrastructure now. And next thing is what we'll do is we'll go ahead and, deploy our .NET app into this infrastructure. So I believe, did I make the change? Okay. I think I kind of missed to mention the stack. Okay, in the interest of time, I'll just go ahead and set it as .NET. So just to explain what is the mistake I did is if you go to this part here, right, in the documentation, so the site config, and then we have something called these versions. Okay, you can set up what is the .NET version you want to set up and everything. Okay, so that part I missed it to add. Yeah, Linux web app. So now this is changed like this. Dot underscore version I should have provided either 3.1, 5.0, 6.2, etc. That's why it is. Without that, basically, when we deploy the .NET app, it wouldn't work. So just in the interest of time, I'll just go ahead and do it manually. Ideally, you wouldn't do that, right? Everything you want to make it via Terraform. So in ideal way, if you have to fix it in my office, I will just go ahead and again modify that particular Terraform code, which is having that particular snippet, right, where we have defined the uh, web app. So in this, I need to add that basically. So after the site config, there are also app settings or some other thing is there, right? Inside that, we need to basically add it. So if I do that, then I have to create PR and other stuff. So just for us to move further in the demo, I've added it directly there. Okay. So that's about that infra creation part, right? I think we were able to do the PR part, and then we also did master branch, right? Now, okay, let's see how we can go through our or what we can do with our .NET based thing, right? So one of the things we'll also quickly fix this. Okay. Now this branch doesn't exist anymore. Stash and checkout. Okay. Okay. Now, okay. Cool. Okay. So yeah, now we have this, and everything is present here, right? So here is where you would say paths, and then say it is .NET dash web API. And then single quotes is it? Okay. So this workflow doesn't run, and we'll also set up the same thing for here as well. Right. Okay. So now this is fine. And what we are doing is actually, yeah, I think I can ignore this, considering we already have this here. Right. It's just going to be repetition there. Yeah. So, okay. So now yeah, I was talking about the deployment part, right? So I think we also saw how the CI works for the .NET part. How much time I have? Okay, 10:53. Yeah, so we did go through the .NET CI part, right? Now we'll see how we are going to deploy it into this, right? So this is an existing one. Like this, I'll also add another job called deploy to production. But before that, let's understand this part, right? So this is another job which we created telling deploy to dev, right? What we are doing is this is going to run on Ubuntu latest. So with, like, if you can see, this is one of the jobs. Within the jobs, we have these multiple things, right? So this job, and this is another job, and this job is going to run on Ubuntu latest. And here is where we'll define the environment. So line number 44. Okay, this is where I'm telling this is an environment. So that means to perform this deployment, whatever the secrets that are present inside this environment is what would be considered. Okay, and this is how you'll mark a dependency for another job. So here we say deploy to dev, which needs build. That means whenever build is complete is when this deployment would start, which is what you would see here. Right, if we go to actions and then I go to .NET build, you see this linking build to, and then after build is complete is going to deploy. This is because this deploy to dev needs this one. You can have multiple such things. You can also have multiple jobs needed at this after a build. If you want to, let's say, push it into some container registry, and then if you want to push it into maybe app service and dev QA environment in parallel, you can very well do all of those here at this stage. Okay. And what we are doing is, first thing is we want to download the build artifact, right? So that is the action for that. We download the artifact, and the name of the artifact is this, and it's present in this particular folder. if you go little above in the build step, we had just done that, right? We've uploaded the artifacts here, and then the same thing is what we are trying to download here. And once we have the artifact in place, right, next step is deployment. Now we are trying to deploy it into Azure Web App, right? So for that, we have a built-in action available, which is Azure/web apps deploy, and the app name is this web code trial, and this is the published profile, and this is the package. So it's typically the same thing what you do when you are doing from either VS Code or from Visual Studio. You right click and then you do a publish into Azure app. The similar thing you're trying to do with then GitHub Actions now, right? So let me also quickly show what is that we are deploying here. I think I've been talking about the .NET app, but I didn't show what is that app, right? So it's just a basic .NET Web API, the default template what we've got, which has it weather forecast controller, right? So if I can browse that from the deployed version, if I go to code trial web, and I'll do this / weather forecast. Right, it just gives this. Basically, it has an array of 5 weather details is what it is giving, right? So what we are going to do now is we are going to deploy this version first into the production, and then we will see how we can make code changes and then how we can take that into production next as a 2-step process. Okay, so I will go back here, and we will add another deployment job, okay, into this. The easier way is, yeah, you can just mimic everything as is, right? You can just copy paste the entire stuff. Now I'm going to say this is deploy to prod. Okay, deploy to prod, and I'm okay to run this in Ubuntu latest. And here I would like to use prod. Okay, and this needs maybe deploy to dev, right? So once my deployment to dev is complete and if it's validated, I want to deploy this into production. Of course, in your real world, you will have multiple environments. You can promote from dev to QA and then to PP and then to perf, and then whatever environments you have in place, you can do all of those. For simplicity, I'm just taking only 2 environments here. So I'm going to say deploy to dev, and I'm going to push this. And now this all same. Now when it comes here is where I need to change the app name and other things, right? So now the app name is going to be the new app which we created via our Terraform, right? So I'll go here, and then I'll say web code demo prod. Okay, and now see this secrets, like I said, this secrets should come from the environment prod, right? But if you go back there, do we have a secret available there? I doubt, right? We have not really set up the secrets there. You go to environments and go to prod. We have these rules, and but there are nothing called secrets here, right? So then we need to add a secret. And what is the secret name that we would need to add? Is that Azure Web App Published Profile. And the profile is something which we can get it from the Azure portal. So I'm going to go here, and then I'll say get published profile, and it is going to open that published profile here. Okay, so I'm going to copy the entire published profile and then add it as a secret there. Okay, so now what would happen is when this guy runs, when this step runs and when it looks for the published profile, it will understand, okay, it needs to pull it from the environment. That environment is prod environment. If we don't specify anything at an environment level, then it will go and look at the repository level. If it is not there at repository level, then it will go and look at the organization level, and it will go up like that. Right? Okay, so I think we should be good. So yeah, code demo prod we did, Azure Web App published profile, and we are doing all this. I hope we are good then. And actually, I'll go over and clean up that other one, which is of no use. Not live demo, delete. Again, new branch. Feature / prod deployment. Okay. So yeah, I'm in this branch now. So I have 2 things. One, I deleted this, and the second one is I added the deploy to prod. Okay, cool. Job for prod deployment. This publish branch. Okay, hopefully that should trigger. Actually, I think it would not trigger. Maybe, yeah. Let's go and see that. So yeah, so we have added this, and pull request needs to be created. So basically what you would also, another thing you would typically do is in this steps, right? You can add the feature branch also. Basically these build and other steps you would definitely add for all the branches, right? Because you need to compile the code whenever you are writing a code, and then whenever developer pushes the code into a feature branch also. So you'll definitely have some of these basically feature branch also added here. Feature slash star, you can add it, so that all the steps run, and wherever you want to run specific steps for a specific branch, you'll put those conditions like with using if conditions. So now I'll go ahead and create this pull request. Yeah, so this branch has not been because there are no checks which are running here. In for this case, it is not showing up. Okay, that is the difference which I wanted to show also. And if you recollect on the Terraform part, I had added that checks on pull request, on any creation of pull request for that particular branch, so it was doing it. And now since we made modified only the workflow files, right? It's not really triggering any of the jobs. So I will go ahead and merge this pull request. Okay, delete branch. And now if we go into the actions also, we might not see, yeah, the other one is deleted now, right? Because we kind of cleaned that up. And we are not running this for this workflow file changes. So I will go ahead and run the workflow. So yeah, so this runs. And now as you can see, the build happens, and then it goes to deploy to dev, and then it is going to deploy into production also, right? And I think we have set up the environment approvals for production, right? If that is there, then whenever we need to, yeah, okay, it is there, good. So this should complete, and then this should complete, and then it should wait here for my approval, and then once I approve is when it will go ahead and deploy that into the production. Okay, any questions so far?
No, sorry.
Okay, wait, let's give a few minutes. We can also go and take a look at this. As you can see, it has downloaded the artifact from that particular folder, and it is trying to do an Azure web app deployment. Okay, that is also done. Okay, see, it says it is, you see that it is waiting for the approval. It's waiting for review. Prod needs approval to start deploying changes, and timer is, it has 9 minutes. I've just set this timer up. You can also always put it to any number which is comfortable for you, or you can also ignore the timer, right? So now I'm gonna say review the pending, and then I will say approve. Okay, good to go. Ship it. Right. I will just say approve and deploy, and then this should now start the deployment job as well. Oh, okay. I think this wait timer. Sorry, I think I put it wrongly. It's waiting for that time to start. Yeah. Okay. Yeah. My bad. So basically, after you deploy to one dev or anything, you need to also do some testing and things like that. So this is primarily for that purpose. We can add this wait timer, right? So that means before deployment to previous environment and to this environment, it will wait for this much lead time, so that it is able. We'll have the time to run the tests and other stuffs, and then it will start deploying there. Okay. So yeah, so that means we would need to wait for another 8 minutes. My bad. That was my bad configuration. So yeah, what I will do is meanwhile I'll go ahead and remove this wait timer, so that the subsequent one at least would get deployed immediately. Yeah. And in the interest of time, I'll maybe cancel this workflow, and then we'll trigger a new one, so that we can see that also in live, right? Okay, it failed. Go to .NET build again, and then say run workflow. Let's see, the other one should get complete, and then we can quickly check the last part around the CI CD for the .NET part. Let me grab some water meanwhile. Okay, now I think this should be pretty little faster. So again, just to reiterate, in this demo, we are looking at Azure-based deployments because I thought .NET and Azure are this is a community what the people are more comfortable with. But it also has a lot of other options to deploy into any cloud and any language and other things, any platform, etc. Okay, let me go back to my demo notes as this happens to see where we are. Okay, all these are there. Okay, yeah, I know this is coming from different branches. CD deploy to Azure is what we are doing now. We have set up the prod infra, published profile, and perform deployments with approvals. Yeah, we are just one step away from our last demo. Okay, this is done. I will approve. Okay, now this should start. Been approved. Okay. Yeah, it sets it up and then it should complete. And once that is done, we should be able to see our web app live here. Right, if you now click through it, it says it's just running, right? Because this is showing up the default one. And when I say here weather forecast, there's nothing there. And we should see that working when our deployment is complete. Okay, it says deployment is complete. And or all of these, you will get an email notification. Whoever is part of the repository, you will by default you will get that notifications. And if you want to push this into any of the teams, Slack and things, all those options are also available. Yeah, there you go. So we were able to basically set up a deployment pipeline to deploy it into prod in maybe less than an hour or so, right? That's how easy it is. And now let's quickly, test this by checking the entire CI/CD part, right? So I'll go ahead to this particular guy, and I'll maybe increase it to 10. It's just a quick change, right? That means we should be seeing randomly 10 different dates. Now, if, as you can see, there are only 5 entries in this particular array, right? We'll see how it is going to work now. I shall change it to 10 branch slash add more data. Okay, so I am going to just this data as publish branch. Okay, we'll go back here. I can already see that it's available here. I'll create a pull request now. Pull request. That's interesting. Why my .NET workflow didn't get triggered? Let's go ahead and fix that then. So what do we have here in the workflow? .NET dash web API slash, right? That's, okay. I think start dot for the file name I should have given. That's the same thing I did. Yeah, star dot tf. So the similar thing I need to do here. Maybe star dot yes. Expected array. It works here. Why doesn't it work? Oh, okay. Non notation is different. Okay. Now let's also push this into the same branch. Let's see for C# file changes. Yes, sync changes. Yes. All right. Let's see now if this runs. Yeah. Okay. There we go. Yeah. .NET build pull request it started, right? But I think I missed another part. Okay. Yeah, I realize it now. Yeah, I didn't put any if condition here. If you recollect, if you look at here, right, it says deploy to dev here, right? Ideally, what I should have done is I should put an if condition telling this deployment should happen only for a master branch push. That part I didn't do here. So obviously this PR also wouldn't get it pushed, but that is something, yeah, we can always fix. But you get the idea, right? See, again, that is why it says build is complete deploy to dev, and this itself will go and deploy into production, which is not what we intended to do. But yeah, all those fixes can be made, and we can add those checks and balances here in our jobs. So basically what we need to do is this. For this one, we need to add a check called if github.event is push and branch is master. If we put that, then this check, this part would run only for that particular piece of conditions. Yeah, see, now everything happens. So this has an branch protection rule, right? That is what has kicked in now. This check failed, it says. But it doesn't tell anything else. Huh? Yeah, so how it failed is though I made mistake in the file here, since I added the branch protection policies there, I think we are covered. Right, I'll explain what happened. Right, so here what we did in the deployment branches, we said it's only from master branch, right? So that is how we kind of protected ourselves by an inadvertent failures or misses. So because this is not coming from the branch, basically this PR is not deployed. Sorry, because it is not coming from the master branch, this PR is not deployed into the production, which is good for us now. So I'm good with this. So I'll go ahead and merge this PR, and then we should be able to see that getting deployed into the production. Okay. Confirm merge. I'll delete the branch. It mentioned an error being deployed. That's okay. So it's failed in one, and it is not. It's not deployed to the other one, which is fine, which is as intended. So we are good. We go to .NET build. Yeah. So now I think the merge pull request started. Now all these things should work seamlessly. Yeah. I think that's pretty much what I had. Let me check my demo notes again. Yeah, I think we did all of these things, right? Cool. Oops. Right. Any questions? I think it's what 1 hour 12 minutes. Okay.
No, so
Okay. I hope you learned something new, and maybe let it complete the deployment. Then we can, when we fire this request, we should see it is more. It should save more data. So I'll go to go trial. See, this is our dev environment, the trial part. So in that, I see I can already see the data is increased. The same thing should happen in the prod. Diamonds. Okay. Yeah, just another couple of minutes, and then I think we should be good. I hope the repo is shared already, right? Yeah, okay, that's good. Yeah, I think its deployment is complete. Let's go back here. Yeah, there we go. I think, yeah, now as you can see, our new code is deployed. So that's how we can basically, supercharge Azure developments, the deployments, like I called out in the title. So you can, as you can see, you can create infrastructure much faster, be it using Terraform or ARM or Bicep or whatever be the infrastructure as a code. You can use actions to get that infrastructure created in an automated fashion. And then you can also use this for all these code changes, right? You can set up the CI/CD for Azure App Services, what I've shown here. I also have other repositories which has different demos. If you want to look at the other GitHub Actions code, right? So there's something called AKS ones. Here we are deploying a Blazor application into an AKS in a containerized fashion. And then there are also, I think this talks about the function app. And if you want to deploy a function app into an Azure functions, basically, right? Then you can do that here. So like how we have for the Azure web app, we also have something called function apps, where function apps action. So that is what you can use to do that. And there are also other reports, like I said, AKS is also, I have a demo available here. And yeah, you can take a look at this. And about the matrix build, whatever I was talking about, I think I showed it in another event earlier. So I'll just quickly show as a reference, right? So you would do something like this: strategy as matrix, and you are specifying the dotted version as 5.0.x or 6.0.x, and then you say in which one it is running. And then automatically this job would run on these two different versions. Okay, so if you go to that, I think multi-target.net build. Yeah, see, it says running build on version 5.0.x and running build on version 5.6.0.x. Okay, so that's how you would use a matrix build to target your or target the build for multiple runtimes or multiple using multiple SDKs and everything. So there are multiple how to say GitHub Action related demo codes are available here. So please feel free to take a look at it, and then let me know if you have any questions and things like that. Yeah, and I think that's about it. So if there are no questions, thank you so much for taking time to learn about GitHub Actions today. We'll be happy to help you if you reach out to me via Twitter or GitHub or wherever, or LinkedIn, anywhere. Yeah. Thank you. Over to you, Suhas.
Yeah. Thanks, Swami. So, guys, if you have any doubts regarding this session, like you can reach out to him. So, this is his Twitter handle at SV Swaminathan. And so, if you also in future, once you see this video and if you have any doubts, just post it in the comments. Like I'll try to reach out to him and we'll try to clarify the doubts.
Yeah.
So, and if you have, and thanks for the demo, Swami. Like it went, it was good
Mhm.
actually. Like we understood the entire end-to-end flow of it. So, thanks for that.
Mhm. Thank you. I'm
And
glad you found it
yeah.
useful.
Yeah. So thanks, Swami.
All right. Thanks, everybody. Have a good weekend. Bye bye.
Yeah,
Yeah.
yeah, I think okay. Okay, so I think that went fine. Like as I mentioned earlier, if you have any doubts, you can reach out to him. So I also mentioned this Twitter handle in the description of this video. You can reach out to him. And as I mentioned, in the during the start of this session, so we have an event next month which is called as Global Azure Bootcamp, which is going to conduct, which is an in-person event we are planning to do it in Coimbatore. So it is going to be organized in a company called Kovai.co, which is located at Hanudev Tech Park, so which is in Navi, India. So those who are interested to attend the in-person event, so this global Azure it will be focused more on Azure and .NET and some topics on Angular plus Azure plus .NET. So main focus would be Azure. So this is a kind of a full day event. As you can see, it's from 10 a.m. to 3 p.m. and we provide the food and maybe we provide some goodies, but it depends. So it's a kind of a full day event. So still the registration are not up yet. So maybe we'll start the registration this week. If you are interested, you can just join us. Like this is our first in person event after 2 years, I guess. So due to this COVID, we were doing it as virtual. Like this is our first in person after lockdown. So those who are interested, just join us at at COVID.co at Hanwave on Global Azure. So just you can also follow up this meetup group. Like if you go for meetup.com/technique360. So this is our meetup group. Um, if you land on this page, so there will be a join button here. You can click on it There'll be a join group button here. You can click on that. Like, what's the purpose of it is whenever we create event or whenever we schedule events, you'll be notified. So that's the usage of this meetup. So already we have around 2,500 plus members. Like, if you are interested, you can join us this group. So once again, thanks everyone for joining, and thanks Swami for the testing session. The demo was really good. So thanks for that, and thanks everyone for joining us on this Saturday, and keep supporting us. And if you have any feedback, either positive or negative feedback, you can DM us in Twitter. So the Twitter handle is Techme360, or you can also provide us feedback in Meetup. That's also feedback option available in meetups. You can also give your feedbacks, which will help us to improve in our future events. So thanks everyone, and stay safe, guys. We'll meet next month. So thank you.
Yeah. Thanks, everybody. Thank you, Suhas and Techme360 for organizing and having me here. Thank you. Bye bye.
Thanks a lot. Thanks.